started. Quadratic functions, they're doing application problems today. So please listen. A quadratic function makes a parabola, right? So anytime we're doing application problems, we're talking about things that make parabolas. Like when you throw a ball up in the air, it doesn't just stay there, right? It goes up at a trajectory, comes down the opposite trajectory. It makes a parabola. When we launch a rocket, it goes up at a certain angle, comes down at a certain angle. So there's always gravity acting upon it. So we are assuming in every problem, this is that note, I'll go back to talk about this stuff in a second. We are always assuming it is under the sole influence of gravity. There's no thrusters behind any rockets we're talking about. There's nothing else behind it besides gravity acting, pulling it down. Okay? So that's what this negative 16 and that negative 4.9 are. Any of you guys ever taken physics? Or I don't know if you're doing chemistry or biology. But that's gravity. Negative 16 feet per second is gravity. Right? Negative 4.9 meters per second is gravity. That's how fast or how heavily gravity is acting on something. So, anytime we do an application problem, the x-axis or the x variable will always be time. Alright? Maybe that's important to write down. I don't know. The x-axis or the x variable will always be time. The y-axis or our function, right, h of t, will always represent the height of an object. So your x will always be your time, your y will always be your height. Every time we do an application problem. Right? So when it's asking us for height, it's asking us for time, we'll know which variable we're looking for. So, like I said, these are our formulas. H of t equals negative 16t squared plus initial velocity times t plus initial height, if we're talking about feet. Negative 4.9 t squared plus initial velocity times t plus initial height, talking about meters. No, you do not need to remember those. Right? Any application problem we give you will either start with an equation for you or it'll put that in it. Right? We're not expecting you to remember those formulas. Okay? But you do need to understand negative 16 talks about gravity, negative 4.9 talks about gravity. V sub O, that's initial velocity. H sub O, that's initial height. Alright, it's like where something's starting at. Does that make sense? Okay, we all understand that? Okay, so let's try some problems. Let's talk through a few. Our first one. Jason jumps off a cliff. Please don't go jump off a cliff to prove you're good at math. So Jason jumps off a cliff into the ocean while vacationing with some friends. His height as a function of time can be modeled by the function h of t equals negative 16t squared plus 16t plus 136, where t is the time in seconds and h is the height in feet. So it gives you a function, right? It gives you negative 16t squared plus 16t plus 136. So then what it asks is, how long did it take for Jason to reach his maximum height? How long did it take for Jason to reach his maximum height? What's it asking for?
How long?
How long? It's asking for our x variable, but at what point? Oh, I heard someone say it. The vertex, right? At the maximum. Maximum height, that means our vertex. Right, if we're looking at the maximum. So we need to find our, how long, our x value at the vertex. Well, if it's an equation in standard form, how do I find the x variable at the vertex? Not just b over 2a. Negative b over 2a, right? In standard form, which this is, my x value at my vertex is negative b over 2a. We've done this, right? My negative b, so b is 16, so I get negative 16 over 2 times, well, 2 times negative 16, right? So I get negative 16 over negative 32, 1/2. Well, 1/2 what? Seconds. It takes him 1/2 seconds to reach his maximum height. Well, does that make sense? If you jump off a cliff, how long is it going to take you to start falling? Like that, half a second, right? So 1/2 seconds is how long it took him to reach that peak, and then he's going to start heading down. Okay? Would it make sense if it had said like negative 1/2 seconds? No, right? We gotta think through some of these too, guys, alright? If it gives you a negative time, sometimes that's not a good idea. Okay? What is the highest point he reached? In other words, what is his maximum height? Well, once again, it's at our vertex, but it's not the time, so we're not looking for x, it's the height. So we're looking for the y value at our vertex. So y value at vertex. Well, how do I find the y value at my vertex? Ange? Plug in your x value, right? Plug it in for t. So we had, was that negative 16 times 1/2 squared plus 16 times 1/2. What was his initial height? What was the ending number? 136. Thank you. So go ahead and punch out your calculator if you want. Do it in your head. Negative 16 times 1/4 plus 8 plus 136. So that's negative 4 plus 8 plus 136 is, you get 140? 140 what? Feet. Is it feet? Right? Height is in feet.
R.I.P. Jason. The next question.
Okay, so he's 140 feet in the air at his maximum height before he starts going down towards the water. Does that make sense? Right? If it's asking for height, we're plugging in, trying to find y. If it's asking for time, we're trying to find x. Okay, the last question on here for this problem. Jason hit the water after how many seconds? So, well, we're looking for what? Time, right? So we're looking for an x value. So we got to try and figure out, how do I find that x value? What is 0? That's his what? That's his height when he hits the water. So if my function's my height, I can set that whole function equal to 0. Right? Does that make sense, guys? 16t plus 136. Right? When he hits the water, he's 0 feet above it. So we set it equal to 0. Now can we solve for x?
Quadratic equation.
You can do the quadratic equation. Very good. So, you can try and factor it or something. I don't know if it works out to a nice number. I highly doubt it. So I'd probably do the quadratic equation. Right? So x equals negative boy, couldn't decide. You want to go to radical party? Being squared. He didn't go. Missed out on 4 awesome chicks. Party wasn't over until 2 a.m. Right, and we're just going to solve from there. Guys, when we're doing application problems, stuff like this, we are going to be okay with rounding decimals at the very end. Okay? So, let's start here. We get negative 16 plus or minus the square root. What does that become? 256 plus 8,704 over negative 32. But you get negative 16 plus or minus the square root of 2,960 divided by negative 32. Right?
Where'd you get 2,960 from?
Yeah.
That doesn't make any sense. It should be 8,960.
I wrote it wrong in my paper, sorry. 8,960. Okay? Alright, from here, because we said we don't want to round it to the absolute end. In your calculator, you should put in negative 16 plus square root of 8,960 over negative 32. And you should put in negative 16 minus square root of 8,960 divided by negative 32. I would like you, when you put that in your calculator, please round it to, let's say, 2 decimal places. So anytime we're doing application problems, it's okay to get a rounded number. Someone put it in their calculator? Anybody? Okay, so you got the first one here? Andrew, did you get? You got this one? What did you get? 2 decimals.
3.46.
Okay?
Wait.
So 3.4 seconds for the subtraction. Okay? Did anyone get the addition one? Taylor, what'd you get?
Negative 2.46.
Negative 2.46?
Wait, I got it flipped.
Uh-oh.
I got negative
point.
Negative 2.46 and 3.46 are
Oh
good.
wait, I got negative 2.46 and 3.7.
Hey, if you need to, guys, do it one piece at a time. Do the numerator, hit enter, then hit divided by. Hey, if you don't put that, if you try and do all 3 pieces at once, and you don't put a parenthesis after your radical, it does this number divided by negative 32, and then square roots it.
Wait.
So maybe do like, in your calculator, type in negative 16 plus square root 8,960. Enter. Divided by negative 32. Now to eat the right answer.
Yep.
Okay, you gotta be very careful. So in, he hits the water after negative 2.4 seconds. Does that make any sense? No, negative answer does not work here. He can't go back in time to hit the water, but he can hit the water in 3.46 seconds. That is a good answer. Okay, so you gotta be careful. Think about the answers you get. Alright? Any questions? Okay, let's keep going.
What if there's one that's positive? Oh wait,
Never mind? Okay.
So one has to be negative.
But not necessarily. We'll see a problem where they're both positive in a little bit.
Okay.
We will come across that situation and that'll be okay. We'll talk about it.
Okay.
So, you're trying to dunk a basketball. You need to jump 2.5 feet in the air to do so. The height that your feet are above the ground is given by the function negative 16t squared plus 12t. What is the maximum height your feet will be above the ground? So I want the maximum height, which means I'm looking for what? What part of my vertex? The y value of my vertex. Remember, y is height, so y value at vertex. So, to find that, I'm still in standard form. I need to find the x value first. Negative b over 2a. So negative 12 over 2 times negative 16, or negative 12 over negative 32. Oof, does that come out to a nice number?
3/8.
What does that come out to? 3/8? Good. 3/8. Let's leave it as that because it's easier to plug in, right? So we got 3/8 for our x value, which means plug it back in to find your y. Negative 16 times 3/8 squared plus 12 times 3/8. Alright, so go ahead and you can put it in your calculator if you'd like to. I think it comes out to, is that negative 16 times 9 over 64 plus 36 over 8.
Yeah, I got 2.25.
Oh, I'm gonna get there.
Oh,
I'll get there. Don't worry.
I thought he was saying 9 over 6.
Negative 144 over 64 plus 240, 48, 288 over 8, which over 64, excuse me. 44 over 64. What? Someone put that in the calculator. 144 over 64. What'd you get?
2.25.
Perfect. 2.25. So you got 2.25 feet. Obviously, if you just put it in your calculator, it's perfectly fine. I chose not to. We got the same answer, right? So, he got 2.25 feet at his maximum above the ground.
Weak.
Will he be able to dunk the basketball?
No. Just 2.
How many people think yes, he can dunk the basketball? How many people think no, he cannot dunk the basketball?
It depends on how tall.
Hey, Aubin, why is it a no? Right, yeah, it said in the beginning, you need to get 2.5 feet in the air to dunk the ball. So if we only got 2.25, can't dunk it, nerd. Alright. Come on, alright. I don't want to do this one. Yeah, we'll do this problem. Here we go. So a diver standing on a platform 24 feet above the pool. He jumps from the platform with an initial upward velocity of 8 feet per second. Use the formula h of t equals negative 16t squared plus initial velocity times t plus initial height, where h is his height above the water, t is time, v sub 0 is his starting upward velocity. H 0 is starting height. Hey, pay attention. Quit talking. We need to write an equation. How do I write an equation? Plug this stuff in, right? V sub 0 is his starting upward velocity. Well, what's it say his velocity is? Initial upward velocity of 8 feet per second. So h of t equals negative 16 t squared plus 8t. H sub 0 is his initial height. He's standing 24 feet above the pool, so that's his initial height. So plus 24.
Are we gonna have to remember these equations? Like,
Nope, you do not need to memorize them.
um,
How long will it take for him to hit the water? Well, how do I figure that out? How do I figure out how long it takes him to hit the water? Set it equal to 0. We're solving for x, right? We want to see the time. So we got to set it equal to 0 because we want to know when his height is 0. We want to know when he hits the water. So 0 equals negative 16t squared plus 8t plus 24. Well, how are you going to solve that? Quadratic formula, right? So, negative b plus or minus the square root b squared minus 4 ac all over 2a. Hey Johnny, how's the problem going?
We're arguing about rec basketball.
Oh, that's kind of what I figured because I could hear you all the way up here.
Mr. E, are you playing music on your computer?
I hear it. You're gonna
Is
get,
it?
you're gonna
Is
get
it so
copyrighted.
I hear it also.
That's alright, I can't hear it.
Thank you.
I'm old, I can't hear it, it's fine.
Oh.
Yes, there's probably music playing. We're not just from anyway, so we're gonna keep going. So, do your math. X equals negative 8 plus or minus the square root 64
Thank God it's a
plus, what is that number? It's a big number, I can't do it. 1,536. Hey, Mr. Hobberich. Over negative 32. Right? All we're doing is math now. Calculations. So we add these together. What do we get underneath that radical?
40.
1,600.
Oh, sorry.
And then, Sarah,
40.
once you take the square root, it equals 40, right?
Yeah.
So, x equals negative 8 plus or minus 40 over negative 32. And we said once we get to this point, do each one separately. Right? Negative 8 plus 40 over negative 32. And negative 8 minus 40 over negative 32. Once again, if it comes out to decimal, guys, round it to the second decimal place, please. Did I go too fast, or do I need to? We good? Do you want me? Do you need to go back? You good? Okay. All right.
Can't be a negative.
So, did we get an answer for that top one? Negative 8 plus 40 over negative 32?
Negative 1.
You get negative 1. So that's negative 1 seconds, right? Okay, negative 8 minus 40 over negative 32. Andrew, what'd you get? 1.5 what? Seconds. All right, let's think about it for a second. If I jump off a diving board, can I go negative 1 seconds before I hit the water?
No.
No, right? So that one, can I go 1.5 seconds before I hit the water?
C.
Perfectly fine. So that is our answer. Taking 1.5 seconds to hit the water. Yes, Ange?
We didn't know that 1,600 reduces to 40. Could we just put plus negative or?
Yeah, you could do like negative 8 plus that square root in your calculator. Perfectly fine. Yeah. Do about 6 minutes. That's all right. We're gonna save another one for another day. So that one's actually day 8. Perfect. Good to go. Sweet. So homework time. Swipe up. Subscribe.